Quotient rule. Hi. That didn't just happen. Okay, quotient rule. I hope this is working. Quotient rule. Hi, Mr. MathWell here. Quotient rule. All right, we've been talking about different differentiation rules. Constant rule, power rule, sum difference rules, product rule. Now we're on to quotient rule. So product rule was the product of two things. How do we negotiate that? How do we find the derivative if we're using the factors, right, as products? This is how are we finding the derivative of like a rational function, let's say, where you have a polynomial on top and a polynomial on the bottom. And how do you take a look at that sort of quotient, that division, and find the derivative of that big thing? Well, there's a special rule for quotient rule too. It's kind of like the product rule, similar, but you can't just take the derivative of f here, like this, and divide it by the derivative of g. You can't just do that. Unfortunately, that would be really nice if if calculus cared about simplicity, that's what it would be, but it cares about accuracy, and so do you, and so do I. Sort of. Okay, so what we're going to do is I'm going to walk you through the quotient rule. So it's kind of like the product rule, like I said, in that you kind of take the derivative of this and then not of this one, and then this one and then the derivative of this one. So it's kind of alternating like the power rule, except the big thing is it's subtraction instead of addition, so that's nice. But here's what we do. We focus on the numerator as a function and the denominator as a separate function. So we're going to call them f and g. So what we do is we take a look at the top. We take the derivative of the top first. So with the derivative of the top function, and we multiply that by the bottom function. Again, no derivative there. So derivative here, no derivative here. So derivative of the top times the bottom. And then because it's a quotient, you want to think minus. Product, you think plus. Quotient, you think minus. And now you flip it. So it's a regular old f of x times the derivative of g of x. All right? That's not a c. That's a bracket. And then now here's the funny part again. So now it's a quotient. So here's the extra funny part. You have to divide now by this bottom function squared. Yeah, I know, that's weird. No derivative, no nothing, just the bottom function squared. And what can I say? That's the way it works out. So that's your quotient rule. We're gonna get some practice here. I am gonna show you a couple things. So you're gonna see on the left, I've done an example with the product rule. So let's say we have a product of two factors here, and we have 1/6 x to the negative 2 times x plus 1. And the product rule would be shown on the left here. Let me zoom out so you can see the whole thing. Here's the product rule, okay? We take the derivative of the first, right here, times the second, plus the first just by itself times the derivative of the second. And then I'm going to simplify, gather like terms, get common denominators, get it all simplified. And actually, we could simplify this even further by taking a negative out, right? You might see it looking like this, okay? Something like that, okay? One of those two. So that would be simplified. And that's the product rule. Now notice that I can actually write this as a quotient because this x to the negative 2, right? That can come down to the denominator. And I can actually write this thing right here like this. X plus 1 up top and a 1 up top. And then on the bottom is a 6 and an x squared. You see that? So this is the same thing, except this is written as a quotient, and we're going to do the quotient rule side by side so you can see if we get the right answer, if we get the same answer. So let's follow through. Here's the quotient rule just simplified just a tiny bit, like f over g, right? So it's f prime g minus fg prime over g squared. So the derivative of the top is 1, right? So we're going to find the derivative of this, right? Just like we found the derivative of this. And so the derivative of the top times the bottom, 6x squared, minus, so there's a big fat minus there, the top. Now here's where you got to be careful because you're going to have multiple terms here. So I would sneak in a second set of brackets there just so you remember to distribute that negative. Because remember, when you minus a bunch of terms, you have to remember to distribute the negative or else you get the wrong answer. And wrong answers aren't as fun as right answers. So the top times the derivative of the bottom, which is 2 times 6 or 12 x to the 1. So 12x. Okay. All over, don't forget this, the bottom squared. Now you could just, I'm going to show it like this, okay, but we're going to simplify that here next round. Okay, so I've got 6x squared up top. That does not look like a 6 for some reason. 6x squared minus, now this is minus what? Well, 12x squared. Thank you. And then minus 12x, you see? Minus 12x. So I did kind of a couple steps at once there. I multiplied this and then I distributed the negative as I went. Okay? All over, this is going to be now 36x to the 4. You can multiply this out in the bottom. You can leave it like this too, because you might be able to factor 6x squared out. I don't know, we'll see. So I can gather some like terms. This is going to be negative 6x squared minus 12x all over 36x to the 4th. I can take a negative 6x out. And I'm left with what? X plus 2. And on the bottom I've got 36x to the 4. And if I simplify that, let's see, the x divided by x to the 4. Well, first of all, let's do this. Negative 6 over 36, that's going to be negative 1 over 6. This x plus 2 is going to stay there. And then the x's, when we simplify the x's, that's just going to be x cubed on the bottom. So as you can see, we really have the same as when we did it with the product rule. That's the exact same value there. Negative x plus 2, negative x plus 2 over 6x cubed. So there's the quotient rule. All right, let's do this one down here as our final example, because that's really all the quotient rule is. And I did want to highlight this actually, because in your textbook you might, or online, wherever, you might see it looking like this. It's the exact same thing, except I always start with the derivative of the top, and they start with just the bottom times the derivative of the top. So I always show it as f prime x times g of x, which is exactly the same thing, except the textbook. You know, I always start with the top. Always start with the top. So you might see it in your textbook like that. It's not different. It's just written. This way. Okay, switched around. So derivative of the top. Okay, so this is f prime of x is going to be, quotient rule says, the derivative of the top, which is 2x plus 2, times the bottom, x cubed plus 1, minus the top. Okay, so here we go, the big top there. Squared plus 2x minus 3 times the derivative of the bottom, which is just 3x squared, all over the bottom squared. Now, remember I said you don't have to expand this out in the bottom? I wouldn't. So if you have a binomial to some power, don't expand it out. Why? Because there's a good chance you might be dividing out a common factor from the top and bottom. So just leave it in factored form. Factored form is simplest anyways, so that's okay. All right, so let's try and gather some like terms up top here. Well, we could do some multiplying, I guess. So this is going to be 2x to the what? 4 plus 2x. I'm distributing here. Plus 2x cubed plus 2 minus. So minus. What's going to be happening in here? Well, this is going to be 3x to the 4. And it's going to be plus 6x cubed minus 9x squared, okay, all over x cubed plus 1 squared. So I can combine some like terms here now, looks like. So I've got 2x to the 4th minus 3x to the 4th. That's negative x to the 4. I've got x cubes, okay. 2 minus 6 is negative 4x cubed, looks like. And those 4's are gone. Yeah, squareds here now. Okay, so a squared. I only have one squared. Yeah, so this is a minus negative, so that's a plus 9x squared. So that one's gone. Taken care of. Plus 2x plus 2. I've got that in descending order of x, which is kind of nice. That's kind of simplified. Squared. All right. And that's your answer, and that's where you're going to be able to stop here. I know this is a polynomial. It's a degree 4 polynomial. You might be able to factor this out of there. I mean, if it says, fully factor, you're going to probably have to check to see if you have this as a factor in this polynomial so you can simplify. But I'll tell you right now, that's just the answer you can stick with there. Okay, so again, it's the quotient rule that we're focusing on. I'm going to show you one more question. If you want to see me take some more time to do these questions, you can look at my other videos on MrMathWell.com or search me up on YouTube there and look for quotient rule videos, and I do some of these examples. But I'm just going to show you the final sort of layout of these solutions. So again, the derivative of the top is 2 times the bottom minus the top times the derivative of the bottom all over the bottom squared. Expand, gather like terms, factor, and there you go. We have our final answer. Okay, and leave the bottom factored form. Totally great, because you may have a factor that you want to divide out at the end, which you should. So this one here, okay, so this one here, you're going to probably want to write this as x to the 1/2, okay? It's just going to be easier to take the derivative when you have fractional exponents. And so this one gets a little complicated in that you're going to have to collect some terms on the top here. You're going to have to get a common denominator, right? And that sort of thing. So again, if you want to see me do this whole question, look up some of my other videos. But here is the solution here. And just remember to get common denominator, right, when you want to add or subtract like terms, if you can. And yeah, that's this one. Derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Okay. And here is, you can take a look at this one. This is a question on computing the domain. So remember, in your denominator, that can't be 0. So there's going to be some restrictions there for x if you're asked for domain. Okay. This can't be 0. This can't be 0. Okay. And so you can compute the domain there as well as find the derivative. So sometimes domain questions creep up on students as well. Okay. Yeah, so that's kind of that for the quotient rule. So there's a quick look at the quotient rule, and yeah, I hope that helps.